In this video, we're going to take a look at the square root principle, which will then lead into solving quadratic equations by completing the square in the next video. So you can solve quadratic equations of the form ax squared plus bx plus c equals 0 when a doesn't equal 0, but b does equal 0, which means that that second term drops out, isolating the square term, and then we can actually take the square root of both sides to find x. So let's take a look at some examples on how this square root principle works. So starting with the most basic one, we have x squared equals 49. So when we take the square root of both sides, we have x equals positive 7 and also negative 7. So you might ask yourself, why does this happen? So remember that x is being squared. So if I have the number 7, I know that 7 times 7 is 49. And I also know that negative 7 times negative 7 also gives me 49. So very nice. You should be checking your answers. And when I check both positive 7 and negative 7, they both give me 49. So in the second example, we can see that the 4 and the negative 1 are surrounding the x squared. So we need to get rid of the coefficient and the constant terms. So I'm going to add 1 to both sides first. So I have 4x squared equals 121. And then I need to divide by 4. So I have x squared equals 121 divided by 4. Now remember, our whole goal is always to get the squared term by itself. Now in this case, the squared term is x. So I'm going to square root both sides. And when you do this, I actually recommend that you put the plus or minus in right away on the side where the square root is. So I'm going to go back here and actually add in the plus or minus on the square root of 49. So the square root of x squared means I have one single x, and that equals plus or minus. Now this is a fraction, but I can still take the square root of 121, which is 11, and I can take the square root of 4, which is 2. So this gives me a solution of plus or minus 11 over 2. Now if we do a quick check, which I'll do on the side here, I'm going to have 4 times 11 over 2 squared minus 1 equals 120. So what I want to do is check the left-hand side here equals the right-hand side. So I have 4 times 11 squared is 121. 2 squared is 4. And then minus 1 equals 120. So I can see that the 4's cancel off. And then I have 121 minus 1 equals 120. And then 120 equals 120. So that worked. All right. In the next question, I put in a fraction to see how we solve questions with a fraction. Now, I like to get rid of fractions because it's harder to work with. So we're going to do that by multiplying by the LCD, which is the lowest common denominator. So in this case, it is 2. We're going to multiply the left side by 2. And we're going to multiply the right side by 2 as well. So it's going to be 2 times a half x squared. So 2 times half means there's 1. So I have x squared. And then don't forget we have to also go 2 times negative 2. So that will be negative 4. On the right side, I have 2 times 5 over 2. And the 2's will cancel off to give me just 5. So this is really nice because now I don't even have a coefficient in front of x squared. I add 4 to both sides. X squared is equal to 9. Square root both sides. Put my plus or minus on the side with the number so that x is equal to plus or minus, and square root of 9 is 3. All right, let's take a look at 3 other ones that are a little bit different. So in these 3, you can see that the x is not isolated, but each of these terms actually have a whole binomial. Okay. So this time what we're going to do is we're going to isolate the binomial squared. So I'm just going to erase all of these and erase this so they can have some space. So the first one in number 4 here, the binomial is already isolated. There's no coefficient in the front. and it's squared already. So I'm going to square root both sides. And like before, I'm going to put the plus or minus on the side with the number. So when I square root the left side, I have x plus 2. On the right side, I get the plus or minus, and the square root of 81 is 9. We're going to subtract 2 from both sides. So now I have x is equal to negative 2 plus or minus 9. Now, we don't leave it as negative 2 plus or minus 9. It is nice to actually get the two solutions. So x is equal to negative 2 plus 9. And we also have negative 2 minus 9, using the plus or minus. So this gives me the two solutions. Negative 2 plus 9 is 7. And negative 2 minus 9 is negative 11. So there are our two solutions again. And then you can check them to verify them that they work. Okay, in the second one, again, the squared is already, the binomial is already isolated, so it's just a square. So we're going to square root both sides. So on the left side, I have x minus a half. Oh, don't forget the plus or minus. On the right side, I have plus or minus square root of 5. Now I can't square root 5, so I leave it in the square root. But the 9 I can square root, so I'm going to take that out and write a fraction line and put a 3 on the bottom. Finally, I'm going to add the half to the right side to get 1 over 2 plus or minus root 5 over 3. Now, sometimes you might see answers where the two fractions are joined together. So in this case, our common denominator is 6. So I'm going to multiply the first term, or the first fraction, by 3. And then the second fraction needs to be multiplied by 2, so that our denominator is 6. So now that we have the same denominator, we can join these two fractions together. So it's 1 times 3 is 3, plus or minus 2 root 5. I can draw one big line because the denominators are the same, and the denominator here is 6. All right, the last one, it's a little bit different from the other two because we do have that coefficient in front of the binomial. So remember, this is the binomial, and this is what we want to isolate because that's the part that's being squared. So what we're going to do is get rid of that coefficient by dividing both sides by that coefficient, which in this case is 2. So now we have x minus 3 all squared equal to 20. Now we have our binomial squared, so now I can square root. So square root both sides, put our plus or minus. So now I have x minus 3. Actually, I don't need the brackets. So I have x minus 3 equals to plus or minus square root of 20. Move the 3 to the other side, so I have x equals 3 plus or minus. Now I can simplify square root of 20. If you recall, you want to find a perfect square that goes into 20, and that number happens to be 4. So I'm going to rewrite this as square root of 4 times the square root of 5, since 4 times 5 is 20. But I can square root 4, so that is 2. So I'm going to rewrite this as 3 plus or minus, and then 2 times the square root of 5. So we get a different kind of answer, which is nice so that you can see the different types of answers there are. They can be integers, such as number 3 and number 4. They can be fractions, such as number 2 here. They can be a different kind of fraction with a square root, or they can also be answers where we get a number, which has to be then simplified.